In this lesson, we're just going to do some practice questions for all the information we've covered so far. So in the first question, we're going to ask, from the table below, circle the fundamental quantity or quantities. And we know that density is not a fundamental, relative density is not, force is not, weight is not, energy is not, volume is not, and charge is not. So the only two that remains is mass and current. In question number 2, we're going to ask, what is the name of the single force which can replace two or more forces? And the answer for this is the resultant. In question number 3, we're going to ask to fill in the blanks for this statement. A block of wood of weight 10 newtons is placed on a table. It will experience a force of 10 newtons due to the table acting in an upward direction. Now, this is because all forces occur in pairs, and a pair of forces will usually act in opposite directions. The weight of the block acts in a downward direction, and if it is placed on top of a table, then the table will provide 10 newtons of force to keep that block in place, and it will also act in the opposite direction. In question number 4, we have to show the direction of the resultant of the forces. Now, we don't have to find out the magnitude, which makes it very easy for us. We are, however, going to require a compass. We're going to take the compass point and put it at this position and open up the pencil point until it touches the end of the arrow at this position. We are then going to shift the compass point over in this direction to the end here, and then we're going to draw an arc at that position. Next, we are going to take the compass point again and put it at this position and open the pencil point up to this point here. We are then going to shift the compass point down this direction to the end, and we are going to draw an arc like this. We are then going to identify the point at which they intersect, and we are going to join a line from this position here and this position here to meet at that point. We are then going to join the starting point here to the end point, which is here, and that will be the resultant line. Now, we just simply have the direction of that resultant. In question number 5, you are required to determine what the mass and weight of a body is when it is measured on Earth and then moved to the moon. Now, your mass will not change since you are not removing atoms from your body. So therefore, your mass on the moon will be m. Your weight of the body depends on the gravitational field strength that it is placed inside of. And since the moon has 1/6 the gravitational field strength of the Earth, therefore that means that the weight on the moon will also be 1/6 of your weight on the Earth. In question number 6, you are required to derive the units for the volume and density of a cube. The equation for the volume of a cube is side by side by side. And all you have to do is replace the quantities with the units. So side is measured in meters, meters, and meters. According to algebra, m multiplied by m will simply be m cubed. And that means the volume units is m to the third power. The equation for density is mass over volume. So replacing the quantity with the units, mass is measured in kilograms, and volume, as we saw earlier, is measured in cubic meters. So we take kilograms divided by cubic meters, and we get kilograms per cubic meter as the units for density. In question number 7, we are required to find the density in grams per cm cube for a volume that has 200 cm cube and a mass of 150 grams. So the formula, rho equal m over v is equal to 150 grams divided by 200 cm cube, which is equal to 0.75 grams per cm cube. We then take this 0.75 grams per cm cube and write it as a fraction and multiply it by two convenient numbers of 1. The first convenient number of 1, we will choose to use it to convert grams to kilograms. And we see that 1 kilogram is equivalent to 1,000 grams. So this here is a value of 1. Again, we have 100 cm is equal to 1 meter. So we know that this here is a value of 1 even if we raise them to the power of 3 each, so that we can get cm cubed. Once we get that, we expand and we simply use our algebra to cancel, and we see that we get 0.75 multiplied by kg multiplied by 1000 divided by cubic meter. And we see the answer is 750 kilograms per cubic meter. In question number 8, it states an unknown material has a relative density of 3.6. What can be said about the weight of the material when compared with water? Assume the volume of water and the unknown material is the same. So we'll first start our solution by simply stating some symbols that we are going to use for our explanation. So we're going to let the relative density be rho r, and this here is the symbol that is required to use for any relative density, rho subscript r. We're going to let the density of the unknown material be rho UKN, let the density of water be rho W, let the mass of the unknown be M UKN, let the mass of the water be M subscript W, and let the volume of water and the volume of the unknown be represented by V, since they are the same volume. Now rho R, which is the relative density, is going to be equal to the density of the unknown divided by the density of water. And that is going to be equal to the mass of the unknown divided by its volume, which is then divided by the mass of water and then divided by its volume. We are then going to see that the volumes will cancel off since they are the same, and we will get the mass of the unknown divided by the mass of water. Now remember that W is equal to M by G, which means that the mass will be equal to W over G. This is a good point to remind you that even though you may not see a link between some of these subjects that we cover or some of these topics that we cover, you must not think of them as being isolated. Notice here we are talking about density, and now we are relating it to the weight. Notice that we can see the mass here can be replaced with the formula W over G. So we replace it and we get weight of the unknown divided by G, weight of the water divided by G, and the G's are the same, so we cancel them again, and we get weight of the unknown over weight of water. Now we have relative density is equal to the weight of the unknown divided by weight of the water. When we state this, we see that we get a value of 3.6 multiplied by weight of the water is equal to the weight of the unknown. Or another way to say it is that the weight of the unknown is equal to 3.6 times the weight of the water. In question number 9, we are going to have 4 forces acting on a body, and we have to figure out the resultant. Now there are 2 ways that we can solve this question, and I'm going to do both ways. So in the first solution, I'm going to use scale diagrams. First off, you must state a scale that you're going to use. I'm going to use 1 centimeter representing 1 Newton. Now remember, when you're doing a scale diagram, you simply draw each force representation as an arrow, and you simply draw each arrow one after the next. So once that is finished, all you have to do now is join the start point to the end point and measure that, and you would be able to get the direction by simply looking at the arrow and the value by simply using your scale and converting it. Now since it is 1 to 1, I use 1 Newton, 3 Newton, 5 Newton and 3 Newton here instead of writing it in centimeters. So that here when you see 4 Newtons, you can understand this would measure at 4 centimeters. You can draw this for yourself and you'll get the same answer. The other way to solve the question is by using vector calculation. So we have to choose first a direction that we consider positive. I am going to choose up as positive and right as positive. So we're going to see about all the vertical forces first. We have 1 3 Newton pointing up and we have a 3 Newton pointing down. Now remember what you have to do when it points in the opposite direction to what you consider as positive. You put a negative sign in front of it and you add all those together. This plus and minus from your algebra becomes a minus, and you get 3 minus 3, which is 0. For horizontal resultant, we do the same. Notice we have a 5 pointing in the positive direction and we have a 1 pointing in the opposite direction. So we put a negative sign in front of it, and this positive and negative sign here will turn to a negative sign, and we get 5 minus 1, which is 4. Now the resultant is found by Pythagoras theorem. We don't need to do it, but I'm just still completing the solution. Right at this point, we can see that it has only a horizontal component, so it points in the positive direction that way, and it is 4 newtons. But say for instance we had a value here, then what we would have to do is use Pythagoras theorem, square it, and we get an answer of 4 newtons. Notice we take the vertical value and the horizontal value and we place them inside here and square it. Then we're going to take the direction as being theta, tan inverse 0 over 4, and we get 0 degrees. And this 0 degrees is really stating 4 newtons and 0 degrees to the direction we considered positive, which is that direction. The last question is a little bit challenging, and I request that you try and answer it before you look at the solution. 3 immiscible liquids A, B, and C, meaning that they can't mix properly, of equal volumes are poured into a measuring cylinder, and they come to rest as shown in the diagram below. Now we are to state what the order of increasing density is for each of these liquids. So first off, let's state what we would know right off the bat. We know that the weight is what is responsible for separating it the way that it is. And since the lightest liquid will be on the top and the heaviest below, then that means that the weight of A will be less than the weight of C, which is less than the weight of B. Remember our formula W equal m by G. We can use this to replace it with the mass. So the mass of A multiplied by G should be less than the mass of C multiplied by G, which is less than the mass of B multiplied by G. Now remember, again, this is not separate, so we can replace the mass with density multiplied by volume. So we have density of A, Vg, less than density of C, Vg, less than density of B, Vg. Each one of these is the same as before. So now we can state, therefore, that the density of liquid A is less than the density of liquid C, which is less than the density of liquid B. In order of increasing is liquid A, liquid C, and then liquid B. So be sure to try these questions before you look at solutions. And if it is you have any problems or you identify any errors, you can simply ask me a question and I will answer you. Thank you.